Okay, we've been given a speed time graph here. It's really a velocity time graph. I would have preferred it if they'd called it velocity, because it is velocity really. Okay, so I'm going to use velocity time for this car, and we're told it travels 1.75 kilometers in 100 seconds. So from there to there, by going through this journey, it's gone 1.75 kilometers. And we have to work out v, this velocity. Okay, so what happens is its velocity increases between 0 and 20 seconds. It's accelerating, then it stops accelerating, keeps going at constant velocity here, and then it decelerates until its velocity is 0. So it comes to a halt after 100 seconds. And during that acceleration, constant velocity, deceleration, it's traveled 1.75 kilometers. The way we're going to solve this is to use the fact that on a velocity time graph, the area under the graph is distance covered. Okay, remember that. Okay, so on a velocity time graph, velocity time graph, okay, area is distance. Okay, remember that forever, right now. So the area on this graph is this whole area here, and that's equal to 1.75 kilometers. So let's work out the area. Let's split it up into that triangle, that rectangle, and that triangle. Okay, so what's the area of this triangle? Well, area of a triangle, half base times height. So area of this triangle is a half times the base, that's 20 seconds, times 20, times the height is v, times v. Okay, so that plus area of this, base times height, that from 20 to 60 is 40 seconds, times the height is v, plus 40v, plus this triangle, half base times height, half times the base, 60 to 100 is 40 seconds, times the height is v, times v, okay? So that's the area, which is equal to the distance, okay? And the distance is 1.75 kilometers, which is 1,750 meters. And we're going to work in meters because the distance, why we're going to work in meters? Because that's in meters per second. Yeah, that's why. Okay. Time in seconds, distance, velocity in meters per second, so convert to meters. Good. Right, so we've basically done it now. We just need to solve that and find v. So half times 20 is 10, that's 10v plus 40v plus half of 40 is 20v plus 20v is 1750. 10 plus 40 is 50 plus 20 is 70. So 70v is 1750. So v is 1750 divided by 70. Cancel the zeros. 7 into 175. This is non-calc, so this is what you have to do, unless you do it in your head. That's brilliant. 7 into 17 goes twice. 14 remainder 3. 7 into 35 goes 5. So v is 25 meters per second. Good. Right, for the last bit, it wants us to describe the acceleration for each part of the journey. Right, so that means this part, and this part. Okay. Right, first part. It says describe. You don't have to work out the value, but let's work it out. There's nothing wrong with working out the value. Okay? You're more likely to get full marks if you do. What is the acceleration from here to here, this first part? Well, acceleration is change in speed divided by time. So acceleration is delta. I'm going to use delta, it means change in. change in speed. No, I'm going to use velocity. I've used velocity so far. We should stick to velocity. We should definitely use velocity because the acceleration is positive here and negative here. I really wish I had used velocity there. Okay, acceleration is delta V. It's a different V to that one. That's a particular V they were asking for. This is just general velocity, okay? Acceleration, change in velocity divided by time. Change in velocity is from 0 to V, and that V is 25. So delta V is 25, and the time in 20 seconds, which is 1 1/4, so 1.25. Units of acceleration, meters per second squared. Okay, so the acceleration for this bit is 1.25 meters per second squared. What's the acceleration for this part of the journey? 0, isn't it? Because the velocity isn't changing. He's going along at constant velocity. He's neither getting faster nor slower. And technically, physics now, he's not changing direction either. So, constant velocity. So there, the acceleration is 0. The acceleration there is 1.25 meters per second squared. For here, the acceleration, again, change in velocity divided by time. Change in velocity is going from 25 to 0. So it's minus 25 meters per second. Okay, it's negative because he's getting slower. It's a deceleration. And the time in 40 seconds, minus 25 over 40. It's multiplied top and bottom by 1.5. Get it over 100. So 25 times 1.5 is 50 plus 12.5, so 62.5. And that is minus 0.625 meters per second squared. So acceleration is minus 0.25 meters per second squared. You might get full marks just for calculating the actual accelerations, just writing that, and that. But you have to describe it, so let's use a few words. So say for this part that, firstly, the acceleration is constant. It's a straight line, which means, yeah, you get that word down. For all three parts, the acceleration is constant. Even that part, it's constant at 0. It's constant at 1.25 there, and it's constant because the line is straight at minus 0.625. Rubbish, isn't it? Okay, so yeah, get the word constant in. That should be minus 0.625. Yeah, and say it's positive here because his velocity is increasing. It's 0 there, and say that it's constant and negative here because his velocity is decreasing. You could also say that you've worked it out. You've looked at the numbers. His acceleration is larger. The magnitude of his acceleration is larger for this bit than for this bit. See, he's accelerating at a greater magnitude. And you could say that you can tell that just by looking at the graph because the gradient of this line is steeper than that. That's more than enough. There you go. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drgem.com, and I'm also on social media. Thank you.